Welcome back to Algebra 2. We are up to Unit 2, Lesson 11. And in this lesson, we're going to learn how to find the point or points of intersection of two polynomials without actually graphing. And the steps are right here. So the steps are to convert both polynomials to standard form if necessary. Then we're going to set both polynomials equal to each other. Then we're going to solve for x by factoring or using the quadratic formula. And then we're going to plug each of the x values into one of the original polynomials to find the y values. So these steps will make a lot more sense when we do the example. So let's look at example number 1. The first step, again, is to convert each polynomial to standard form. So in number 1, my first polynomial is x plus 1, x minus 8. I'm going to go ahead and I'm going to convert that to standard form by using the box method, as we learned about in a previous lesson. So this will be x plus 1 and x minus 8. So quickly, x times x is going to be x squared. Negative 8 times x is going to be negative 8x. 1 times x is going to be x. And 1 times negative 8 is going to be negative 8. So if I put all that together, I end up with x squared. And then negative 8x and positive 1x becomes negative 7x. And then minus 8. So I already went ahead and I converted the first polynomial to standard form. Let's do the same thing with the second polynomial. So we have x plus 2 and x minus 5. So quickly, x times x is going to be x squared. 2 times x is going to be 2x. Negative 5 times x is going to be negative 5x. And negative 5 times positive 2 is going to be negative 10. So that's going to give me x squared. Then I have 2x and negative 5x. So 2x and negative 5x is going to give me negative 3x, right? 2x and negative 5x is going to give me negative 3x, and then minus 10. So that is step 1, is to convert each of the polynomials to standard form. Step 2, set both polynomials equal to each other and then solve for x. So I'm going to take both of these and I'm going to set them equal to each other. So x squared minus 7x minus 8 equals x squared minus 3x minus 10. Now this looks like a complicated equation, but watch what happens. I have x squared on the left-hand side, and I have x squared on the right-hand side. What do you think those two things are going to do to each other? They're going to cancel each other out. So x squared over here cancels out x squared over here, and I'm left with negative 7x minus 8 equals negative 3x minus 10. This is a lot more doable because now I can take all of the x's and move it over to the left-hand side and then move all the constants to the right-hand side. So in order to do that, I need to move the negative 3x over to the left-hand side. So to do that, I'm going to add 3x to both sides. That's the first thing I'm going to do. So negative 7x plus 3x, that's going to give me a negative 4x minus 8 equals negative 10. And now I can take the constant and move the constant over to the right-hand side. So I can move the minus 8 over to the right-hand side by adding 8. So negative 4x is going to be equal to negative 10 plus 8, which is negative 2. Okay. And then I can finish it off by dividing both sides by negative 4. So I'll end up with x equals negative 2 divided by negative 4. That's going to be a negative divided by a negative, which I know is positive. So it's going to be x equals positive a half. So x equals 0.5. All right, so I already went ahead and I solved for x, and I got x equals 0.5. The last step is to plug each of the x values into one of the original polynomials to find the y values. So remember, an intersection, a point on a graph, has an x value and it has a y value. I only found the x value of 0.5. I now need to go ahead and find the y value. So to do that, I'm going to pick one of the original polynomials. So I'm just going to pick the first one, x plus 1 and x minus 8. And I'm going to plug in 0.5 for x. So I'm going to plug in 0.5 for x. Okay, so 0.5 plus 1 times 0.5 minus 8. So we can go on a calculator and do that, or we can use Desmos. I'm just going to use Desmos since that's easiest. So it's 0.5 plus 1 0.5 plus 1 times 0.5 minus 8. And I get a y value of negative 11.25. So y equals negative 11.25. So this particular pair of polynomials only has one point of intersection. The x value is a half, and the y value is negative 11.25. So that is how we write our point of intersection, 0.5, comma, negative 11.25. So that's it for number 1. Number 2, let's do the same thing again. So let's go ahead and convert each of these to standard form. So I have x plus 7 and x minus 4. So x times x is x squared. 7 times x is 7x. Negative 4 times x is negative 4x. And 7 times negative 4 is negative 28. So this gives me x squared negative 4x and positive 7x is going to give me a positive 3x minus 28. So that's the standard form for the first polynomial. The second polynomial is interesting because it's just x minus 4. That is already in standard form. I don't need to do any box method. So x minus 4 is already in standard form, which means I can go ahead and set these two polynomials equal to each other. Okay? Now this one's going to be a little different. As you're going to see, the first thing I'm going to do is I'm going to subtract x from both sides. So that will give me x squared. 3x minus 1x is going to give me 2x minus 28 equals negative 4. All right, so that's the first thing I'm going to do. The second thing I'm going to do is I'm going to add 4 to both sides. okay? Because negative 4 plus 4 is 0. So this will give me x squared plus 2x, and then negative 28 plus 4 is going to be negative 24. So I have x squared plus 2x minus 24 equals 0. That is a quadratic equation. So I have two ways I can solve this. I can use the quadratic formula, which you should have learned in Algebra 1 and geometry, or I can factor. I'm going to choose to factor because this particular equation is factorable. All right, and the way we're going to factor is we're going to look at this number and we're going to look at this number. So we're going to look at what are two numbers that add up to positive 2 and multiply to negative 24. So I need two numbers that multiply to negative 24 and add up to positive 2. And the only combination of numbers that works is going to be 6 and negative 24. If you don't believe me, let's double check it. Is 6 plus negative 4 equal to positive 2? It is. And is 6 times negative 4 equal to negative 24? It is. So the combination of numbers is 6 and negative 4, which means my factors are going to be x plus 6 and x minus 4. Okay? So if I solve these for x, I'm going to get x plus 6 equals 0. I'm going to get x minus 4 equals 0. So this time there's going to be two x values, which means there's going to be 2 points of intersection. So x is going to equal negative 6, and then x is going to equal positive 4. So I went ahead and I found the two x values of negative 6 and positive 4. Now I need to find the two corresponding y values. So to do that, I'm actually going to take the second polynomial this time. I'm going to take this one, x minus 4. And I'm going to plug in, first I'm going to plug in negative 6. And then I'm going to plug in positive 4. Okay? And if I do that, negative 6 minus 4, that's going to give me a negative 10. And 4 minus 4 is going to give me 0. So my 2 points of intersection, my first x value was negative 6. And what was the y value that went with that? Negative 6 minus 4 was negative 10. So negative 6, negative 10 is my first point of intersection. And my second point, my second x value was 4, and the y value that went with that was 0. So I have negative 6, negative 10, and 4, 0. So this particular one had 2 points of intersection. That is it for this lesson.